Hello everyone, welcome to my channel Learn Math with me. Today I am going to explain you introduction about continuity of chapter number 5 class 12. So before starting this video, please like, share and subscribe my channel and don't forget to hit the bell button given below to get the latest updates of my video. So here chapter number 5 is continuity and differentiability. So first of all, let us discuss about continuity. So what is continuity? What does continuity word mean? I think you have all heard about continuous word, right? Which means something which moves continuously. See, here the line is moving continuously without any break. Here I didn't lift my pen, right? If I lift my pen, there's a break. This is not continuous, right? We say this is continuous, this is discontinuous. Okay, continuous word means which moves continuously, which does not have any break. Here we have to do the same in function relation. Now you all get the doubt, what's that in function relation which continuously moves without any break? As you all know, function is like f of x is equal to sin x, f of x equal to cos x, f of x equal to x square and f of x equal to 1x. Now for these functions we have to check whether the given x is continuous or not. Okay, I will explain you through the graph. Let's see one example. Now take y equal to x. Now put values. For x is equals to 0, y is also equal to 0. For x equal to 1, y is 1. For x equal to 2, y is also 2. For x equals to 3, y is 3. Let's plot the graph. This is x-axis and this is y-axis. Right? So, let's plot. X is 0 and y is 0. Here we get the point. And x is 1 and y is also 1. Here we get the point. I think you all know how to plot the graph, right? So x equals to 2, y is also equal to 2. X is 3, y is 3. Here we get. Here. Now let's draw the line. See, okay, this is the line. See here, I didn't lift my pen. The graph is continuous. There is no breaks, right? So y equal to x is a continuous function. Okay, now let's see one more example. Is all the functions are continuous? No. Some of the functions are there which are discontinuous. Now let's see one example. Y equal to 1 by x. Now let's take the values. For x equals to 1, y equals to 1 by 1, that is 1. For x is equal to 0.1, y equal to 1 by 0.1, that is 1 over 1 by 10, because 0.1 is 1 by 10, right? Okay, now 10, y equal to 10. Now let's take x equal to 1 and y equal to, sorry, we have already taken. Let's take x equal to 2. Then 1 by 2 is 0.5. X equals to 3, y equals to 1 by 3, that is 0.75. And let's take some negative values also. For x equal to minus 1, we have y equal to minus 1 by 1, that is minus 1. And for x equal to minus 2, y equals to minus 1 by 2, that is minus 0.5. And for x equal to minus 3, y is equals to minus 1 by 3, that is minus 0.5. Now let's plot the graph. For x equal to 1, y is also equal to 1. Here we get, for x equal to 0.1, we will get y is equal to 10. For 0.1, here the 0 point will be, and here will be the 10 here. Okay. Now for x equal to 2, y is 0.5. 0.5 will be here for x equal to 2, here, and for x equal to 3, 0.75, here it will be. X equal to 3, y is 0.75, means something here will come. Okay, now let's take negative values. Minus 1, minus 1, x equal to minus 1, y equal to minus 1, minus 1 here it will be, and for minus 2 we got minus 0.5. Minus 0.5, I think here we will get minus 0.5 in the center, right? Minus 0.5. And for minus 3 you will get minus 0.75 here. Okay, we didn't take minus 0.1. For minus 0.1, minus 1 by 0.1, that is minus 1 over 1 by 10, that is minus 10. If I take minus 0.1 here it will be, so minus 10. Okay, now let's try to draw it. Okay. See, here the graph is like this. We are not able to join positive and negative values without lifting pen, right? So y equal to 1 by x is not continuous. Now let us discuss about some important note points. Every polynomial function is continuous. See here, you no need to memorize this, just understand how every polynomial function is continuous. Then wherever you get the question when you get polynomial function, then directly write that S polynomial function is continuous. No need to memorize. Okay, let's see the proof, just that's it. Okay, every polynomial function is continuous. Suppose I take p of x equals to a of 0, a of 1 into x plus a of 2 x square plus a of 3 x to the power 4 and so on up to a n minus 1 x power n plus a n x power n, where a is a real number. Okay, a will be 1, 2, 3 and so on up to n. This is a polynomial function and we need to show that polynomial function is continuous. Okay, p of x is a polynomial function and this is defined for all real numbers. Okay, this is defined for all real number. Okay, let us take c be a fixed real number. Okay, now check whether it is continuous or not. To check, let's take limit. Okay, limit x extends to c, p of x is equal to p of c. Okay, now substitute c in the place of x. P of c is equals to a of 0 plus a1 into x plus a2 c square plus a3 c power 4 and so on up to a n minus 1 c n minus 1 and plus a n c power n. Now let's take the limit. Limit x extends to c, p of x is equals to, as we know, p of x. So substitute p of x after limit extends to c. Substitute this, right? After this, as we know, by limit property we can separate the limit. Okay, limit x extends to a power 0 and so on, we all written separately. Then take the constants out. A of 0 plus a of 1, limit x extends to c into x, a2 constant outside, limit x extends to c x square, and so on, an out, limit x extends to c and x power n into multiplied to this. Now as x is extending to c, put c value here, a1c a naught plus a1c plus a2c square plus a3c power 4 and so on up to an c power n. Now see, this limit extends to c, p of x and p of c is same. We proved, right? So p of x is continuous at x equal to c. C belongs to real number. Now one more note. Modulus of x is continuous at every real number. So let's prove it. Okay. F of x is mod x. This is the function which is to define. Okay. By definition, mod x is equals to x comma where x is greater than or equal to 0 minus x where x is less than 0. This is defined on every real number. Okay. Let c be a fixed real number. Here we have to prove this in 3 cases. Okay. Case 1 is when c is strictly less than 0. Okay. Here to prove this, limiting value is equal to the functional value. This is the limiting value, this is the functional value. If they both are equal, then it is continuous. Let's prove the same for all. Okay. Now see, let's take functional value where I have told c be a real number. So f of c equals to minus c. Why? Because c less than 0 means we have c less than 0 minus x. So in the place of x we get minus c. So minus c, f of c equal to minus c, and limit x extends to c minus x. For c less than 0, function is defined as minus x. Minus x is minus c. Okay. Now here the limiting value is equals to the functional value. Therefore the function is continuous at x equal to c, which is strictly less than 0. Now let's see the case 2. Case 2 is c greater than 0. Let's take the functional value where f of c is equal to c, because if c is greater than 0, we have value for greater only x, positive x. So in the place of x, just take c, because we taken c be any fixed real number. So take x in the place of c. Now take limit. Limit x extends to c, f of x, where f of x is x. Because x is greater than 0, we have taken c greater than 0. So just we have to take the positive value, not the negative one, because we didn't take x less than 0. So limit x extends to c, x is c. Here we got the functional value and limiting value, same value, right? C and c. Limit x extends to c, f of x is equal to f of c. So the function is continuous at x equals to c greater than 0. Now let's the third case where c is equal to 0. See, in this case c is a critical point. So for this we have to take both left hand limit and right hand limit. Okay. 0 is a critical point. So we have to take limit, left hand limit and even right hand limit. Okay. So limit x extends to 0 minus. 0 minus means less than 0. For less than 0 we have function defined as minus x. So limit x extends to 0 minus f of x is minus x, because 0 minus means it is less than 0, negative value. So minus x. Now to prove, let's take x as 0 minus h. Limit h extends to 0, where take this minus out and put 0 minus h value in the place of x. So after taking minus out, 0 minus h, 0 0 minus into minus plus h. Okay, as here h is extending to 0, so our answer will be 0. Okay, now let's take the right hand limit. Here limit x extends to positive side, greater than 0. Greater than 0 means we will get this value. Okay, now limit x extends to 0 means positive. After applying limit, we will get f of x is x, right? So x extends to 0. Here the LHL and RHL is equal. Therefore, if function is continuous at x equals to 0, function f of x is equal to mod x is continuous at every real number. Now let's see one more important note point, that is constant function is always continuous. Okay, see here, you no need to memorize any proofs. Just remember in your mind that these note points, whenever you get the same question, just directly write yes, the constant function is always continuous, or the polynomial function is always continuous, like that. Okay, now the constant function means what? It is like y equals to 1, or y equals to 30, or y equals to 10, or y equals to minus 10. So basically f of x is equal to c. If I am considering f of x equal to c as my constant, then what is its domain? What is the domain of this function? Domain is real number. Domain is nothing but real number. Okay, to prove, let's take the limit. Here also same, we have to prove. Here also same, we have to show limiting value is equal to the functional value. Okay, limiting value is equals to the functional value. As we know, domain is having all real numbers. So let's take a, which is an arbitrary real number. Okay, let's take a. Let a be any arbitrary real number. Now let's take the limit. Limit x extends to a, f of x equals to limit x extends to a, where f of x is c. As we know, f of x is c. Then take the functional value, where x is a, f of a is equals to c. Now limit x extends to a, f of x is equals to the f of a. So constant function is always a continuous function. See, I already told you, no need to memorize. Just remember that every polynomial function is a continuous function, and modulus of x is a continuous at every real number, and constant function is always continuous. So this is the introduction part about continuity. In the next video, let's discuss some exercise problems 5.1. Okay, this is the end of the video. If you have any doubts, let me know in the comment section.